Hey guys, today we're going to learn how to find the area between two curves. Now here on the graph we have f of x is equal to negative x squared minus x plus 2. And then we have g of x which is equal to x plus 2. Now before I can find these areas, I need to be able to identify which of these graphs here represent these functions. Since f of x is a quadratic, that means it must be this parabola. And since g of x is linear, that means that it must be this line. So now I'm ready to work with these out. We have here to find the value of the integral from negative 2 to 0 of f of x dx. So first what I'm going to do is I'm going to shade the region that represents the area of this integral. So for that, that's f of x, which is the parabola, and that would be from negative 2 to 0, so it's this whole section here. Remember that the area is always bounded by the graph and the x-axis. So now let's work that out. We have the integral of f of x, which is the negative x squared minus x plus 2 dx. When we integrate, we get negative x to the third over 3 minus x squared over 2 plus 2x. And we're evaluating that from negative 2 to 0. So first when I plug in the 0, everything would end up being 0. So this would just be 0. Minus, now I plug in the negative 2. Negative 2 to the third is negative 8. Times this negative here would make it a positive 8 over 3. Minus, negative 2 squared is a positive 4. And 4 divided by 2 is 2. And then minus 4. Work this out, we get negative 8 over 3 minus 6, which we're going to have to put this with the same denominator. So we end up with negative 8 over 3 minus 18 over 3, which equals to negative 10 over 3, and gives me a final answer of 10 over 3. Now we're going to find the value of the integral from negative 2 to 0 of g of x dx. Now what this represents here is the area that is underneath the line bounded by negative 2 and 0 and the x-axis. So it would be this section here. So I'm going to integrate that from negative 2 to 0 of x plus 2 dx. And I would get x squared over 2 plus 2x, which we're again evaluating from negative 2 to 0. If I plug in 0, everything would just end up being 0. Minus, when I plug in negative 2. Negative 2 squared is positive 4, and 4 divided by 2 is 2. Plus 2 times negative 2, which is negative 4. So what I end up with here is 0 minus negative 2. And so my final answer for that area would be 2. Now, for this last part here, it says, how do you think you would be able to find the area of the region between the two functions? And then we're going to find that value. Now, the area that is between the two functions is this part here. That is between the g of x, my higher function here, minus the f of x. So that's exactly what we're going to do. We are going to subtract. In order to find the area between two curves, what we do is we subtract the higher area minus the lower area. So we do the 10 over 3, because that's the area for f of x, minus the area for g of x, which is 2. And we end up with 10 over 3 minus 6 over 3, which is equal to 4 over 3. And that would be the area between those two functions. So basically, we don't have to go through this entire process where you find the area of one function and the other. There is a way of finding the area without having to go through all of that work. So to find the area between f of x and g of x, what you do is you integrate from a to b, whatever the limits of integration would be, And then you subtract f of x minus g of x, where x is equal to a and x is equal to b, so the limits of integration, are the points of intersection of f and g, where f of x is greater than g of x. So basically I put here, you will integrate the high function minus the low function. So you have to be able to identify which one is above the other. So here, this is the same example that we had before that we were working with. So now we're going to test this out. So we're integrating from -2 to 0 of f of x minus g of x. So -2 to 0 of f of x, which is -x squared minus x plus 2, minus g of x, which is x plus 2. And you have to make sure that if whatever you're subtracting the other function, you want to make sure to distribute that negative. So this is the integral from -2 to 0 of -x squared minus x plus 2 minus x minus 2 dx. The 2's here will cancel, and we can combine these two x's. So what I'm finally integrating is from -2 to 0 of -x squared minus 2x dx. And what we get when we integrate would be -x to the third over 3 minus x squared, because it would be minus 2x squared over 2, so those 2's would cancel. And then we're evaluating this now from -2 to 0. So if I plug in 0, everything would end up being 0. Minus. Now I'm going to plug in the -2. -2 to the third is -8 times the negative on the outside will give us a positive 8 over 3 minus -2 squared, which is 4. So I'm going to put this over 3, and we get here negative 8 over 3 minus 12 over 3, which gives me negative 4 over 3. So my final answer is 4 over 3, which is what we got when we go back here once we found the both individual areas and then subtracted. So you can basically do the subtraction first of the two functions and then integrate, so that way you only have to integrate once rather than twice. Let's look at another example. We want to find the area between the two curves from x is equal to 1 to x is equal to 3. Now here you are given your limits of integration simply because these two functions here do not intersect. Now I'm going to call this y1 and this y2 so I can label which one is which. Now it may be difficult for you to identify, but basically if I look at the x squared here, the number that is attached to it will tell you how narrow it is. The larger the number, the more narrow the parabola. This is a 2, and this is 1/2. So y1 is going to be more narrow than y2. So that would mean that y1 is this blue function here, and y2 would be the red function. And now we're going to evaluate this. We're going to find the area between them from x is equal to 1 to x is equal to 3. So we're looking for this area here. So what we're going to do is we are going to integrate from 1 to 3, y1, which is 2x squared minus 8x plus 10, minus 1/2 x squared minus 2x minus 1. So before I integrate, I'm going to simplify this. So I have to distribute this negative. And when I do that, when I want to combine the x squared, notice that this is 1/2 x squared. So I'm going to rewrite this so it has also a denominator of 2. So what we have now is the integral from 1 to 3 of 4 over 2x squared minus 8x plus 10 minus 1/2 x squared plus 2x plus 1 dx. Now let's combine like terms. So we get the integral from 1 to 3 of 4 over 2 minus 1/2, which is 3 over 2 x squared, Then negative 8x plus 2x is negative 6x. And 10 plus 1 is 11. Now we're ready to integrate. So we have this 3 over 2 x squared, x to the third, and then I have to divide by 3, which is the same thing as multiplying by 1/3, minus 6x squared over 2 plus 11x, and I want to evaluate that from 1 to 3. But first, let's simplify this a little bit. This 1/3 can cancel out with this 3, making it a 1. So now I have 1/2 x to the third minus 6 over 2, so 3x squared, plus 11x. Now we're going to plug in the 3. So we have this 1/2, 3 to the third, which is 27, minus 3 times 3 squared, which is 9, plus 11 times 3, which is 33, minus, when I plug in the 1, 1 to the third is 1 times 1/2 is 1/2, minus 3 times 1 is 3, plus 11. What I have here now is 27 over 2 minus 27 plus 33 minus 1/2 plus 8. So what I do is I work out little by little as I keep going. Now I'm going to combine these and then I'll distribute the negative. So 27 over 2 plus 6 minus 1/2 minus 8. 27 over 2 minus 1/2 is 26 over 2. And then 6 minus 8 is negative 2. 26 divided by 2 is 13. And 13 minus 2 is equal to my final answer of 11. Let's try another one. Here we want to find the area of the shaded region R that is bounded by y equals sine of pi x and y equals x to the third minus 4x. Now keep in mind, remember that sine of x on a graph looks like a wave. So that would be this one here. This wave is y equals sine of pi x. And this curve here, this represents y equals x to the third minus 4x. So now we're going to set up our integral. When we set up the integral, notice that in the question, it does not give us the limits of integration. And that's because our limits of integration, if the functions intersect, will be those points of intersection. So we look at those x values. This is x is equal to 0, and this is x is equal to 2. So my limits of integration would be from 0 to 2. And then I have to do my high function minus the low function. The high function is the sine of pi x. So we would do sine of pi x minus the lower function, which is x cubed minus 4x. So let's distribute this negative and then we'll go ahead and integrate. So we have the integral from 0 to 2 of sine of pi x minus x to the third plus 4x dx. So now in order to integrate this sine of pi x, what I'm going to do is I'm going to write it separately. You don't necessarily need to do that if you feel confident in integrating using pattern recognition. However, just in case, I will be separating this integral. So what we have here is the integral from 0 to 2 of sine of pi x. I'm just going to do this part here and then we'll continue with the rest. So in order to integrate this sine of pi x, what I need to do is I need to see this inner function, which is the angle, and the derivative of the angle would be pi, which is basically a constant, or a coefficient. So I see that this pi is not here, so I need to multiply pi, meaning that I would have to divide pi on the outside. So when I integrate it, now that I have the pi here, I basically ignore it, and I only integrate the outer function, which is sine. And the integral of sine is negative cosine. So for this part here, my answer would be negative 1 over pi cosine of pi x. And now I can continue integrating the rest. So that would be negative x to the fourth over 4 plus 4x squared over 2, which is 2x squared. And I'm evaluating this from 0 to 2. So now we plug in the 2 and we get negative 1 over pi cosine of 2 pi minus 2 to the fourth, which is 16, over 4, plus 2 squared is 4 times 2 is 8. Now we plug in 0, so minus negative 1 over pi cosine of 0 times pi is just 0. And then the rest here would just be 0, so minus 0. Now let's work this out. We have negative 1 over pi. The cosine of 2 pi is 1, so 1. Minus 16 divided by 4 is 4, plus 8, minus, and then we have here negative 1 over pi, and the cosine of 0 is also 1. Now let's simplify this. So negative 1 over pi minus 4 plus 8 is plus 4 minus negative 1 over pi, so be plus 1 over pi. These 1 over pi's, they end up canceling. So my final answer is 4. Now we're going to look at when the area between two curves has multiple points of intersection. As you can see here, we have y equals negative 1/2 x to the third plus 2x squared, and y equals negative x squared plus 4x. So when I look at my graphs, this is a cubic function, so this must be the blue curve. This is a quadratic function, so this must be the red curve because it's a parabola. So I'm going to call this one y1 and this y2. So y1 is the blue and y2 is the red. Now we see here that from 0 to 2, the upper curve, the higher curve, is y2, and the lower curve is y1. So we would set up an integral from 0 to 2 of y2 minus y1 dx. And then I want to find the rest of the area between the two curves. So that would be, now the blue curve is on top, so I'm going to add the integral from, now my points of intersection are 2 and 4. So 2 to 4 of now y1, because that's my blue curve, minus y2, my red curve, dx. I just realized that I put this here, it looks like exponents, but you know what I'm talking about. So now let's plug in the functions and work this out. So for this first one here, we have the integral from 0 to 2 of y2, which is the negative x squared plus 4x, minus y1, which is negative 1/2 x to the third plus 2x squared dx, plus the integral from 2 to 4 of now y1, so it's the other way around, so negative 1/2 x to the third plus 2x squared minus y2, which is negative x squared plus 4x dx. Now let's actually do the subtraction here. We have here, this is the integral from 0 to 2. I notice here, oh no, just kidding. So negative x squared plus 4x plus 1/2 x to the third plus, minus, because I have to distribute this negative, minus 2x squared dx, plus the integral from 2 to 4 of negative 1/2 x to the third plus 2x I'm also now distributing this negative, plus x squared minus 4x dx. We can combine some like terms here, right? Because in this first one, we have these 2x squared. Sorry, this is a 2x squared here as well. Okay, there we go. So we can combine like terms. So we have the integral from 0 to 2. I'm going to write this also in standard form. So 1/2 x to the third minus 3x squared plus 4x dx, plus the integral from 2 to 4 of negative 1/2 x to the third, and I can combine these x squared, so it'll be plus 3x squared minus 4x dx. Now we're ready to integrate. So when I integrate this function here, I get 1/2 x to the fourth times 1 over 4, since I have to divide by 4, minus 3x to the third over 3, which is x to the third, plus 4x squared over 2, which is 2x squared. And I'm evaluating that from 0 to 2. Plus, now I'm going to integrate this function. So that would be, I'm going to put this here in parentheses so we don't confuse, negative 1 over 2, x to the third, x to the fourth, times 1 over 4, plus x to the third, minus 2x squared. And I'm evaluating that one from 2 to 4. We can, rewrite this a little bit so it's easier to work with. This would be 1 over 8 x to the fourth minus x to the third plus 2x squared, evaluated from 0 to 2, plus negative 1 over 8 x to the fourth plus x to the third minus 2x squared, and evaluated that from 2 to 4. Okay, that was a lot, but now we're going to plug in these numbers. So when I plug in the 2 to the fourth is 16, and 16 divided by 8 is 2, minus 2 to the third is 8, plus 2 squared, which is 4, times 2 is 8. Now if I plug in 0, everything would end up being 0, so minus 0, plus, now we're going to come over here. We're going to plug in the 4. 4 to the fourth is 256, and 256 divided by negative 8 is negative 32, plus 4 to the third is 64, minus 4 squared is 16, and 16 times 2 is 32. Now I'm going to subtract everything for when I plug in the 2. So 2 to the fourth is 16, and 16 divided by negative 8 is negative 2, plus 2 to the third is 8, minus 2 squared is 4 times negative 2, which is negative 8. So now we simplify this as much as possible. I see here that this negative 8 is going to cancel out with this positive 8. Over here, also this 8 minus 8 will also cancel. And then just a little shortcut here, I also have this negative 32 with this negative 32, which is negative 64. So these two negative 32s will cancel out with this 64. So what I have now is just 2 minus 0, which is 2, plus 2, which gives me a final answer of 4. Now let's look at a sample FRQ. Now this FRQ is calculator active, so I already have my calculator ready to go. Pictured below is the graph of f of x, which is equal to x to the third over 4 minus x squared over 3 minus x over 2 plus 3 cosine x. and a line L, which is tangent to f of x at the point 0, 3. So first, I want to find the region of R. Now, in order to find this region, I would need to be able to set up an integral. And the area here would be from this x value until this x value, which is 0. That we can see. But I don't know what this x value is. It's somewhere between -1 and -2. We never want to estimate, especially if it's a calculator question. We want to be able to know what exactly is this x value. Now this is the graph of f of x. So what we're looking for first is when f of x is equal to 0. We want to find that x value, that 0. So I'm going to go to my calculator and I'm going to input that function, which is x to the third divided by 4 minus x squared over 3 minus x over 2. Notice that I'm putting parentheses around all of these fractions. Plus 3 cosine x. I'm going to just check my window here. I'm going to place it, the x values you can see from here, it's from -2 to 4. So I'm going to go from -2 to 4. And then for my y's, it seems here that it's from -2 to 4 as well. So I'm also going to place my window here from -2 to 4 for the y's. Now I'm going to graph. I don't know the equation of the line, and that's okay. I'm not going to graph the line. So what I want is this x value here. As you can see, that's this one. So I'm going to go to second calc, and I'm going to go to option 2 for the 0. So remember, it's going to ask you for the left bound, so I'm going to go to the left of the 0, and then to the right of the 0. Guess, sure thing. And I get here that the 0 is at -1.3731. So when I integrate now, what I have to do for region R is going to equal to the integral from that x-intercept, so -1.3731 to 0 of f of x dx. So even though this is a calculator question, still show the integral that you're using, okay, because this most likely would be a point. So I'm going to come here to my calculator because luckily it's going to integrate everything for me. So I go to the second calc menu, option 7 for integral. My lower limit is -1.3731 and my upper limit is 0. And you see how the area that's shaded, you can always verify with the graph here, is the same area for R. So that's my answer, 2.9030. Now for this next part, it says to find the equation of line L if it is tangent to the graph of f of x at 0, 3. So that is my point of tangency. So that's my x, and this is my y, so when I plug it into the line, I already have that. But what I need is my slope of tangency. So I need to figure out what is f prime and then of the x value, which is 0. Now luckily for us, a calculator does this for us. So again, I'm going to come here to the calculator. I'm going to go to my second calc menu, and I go to option 6 for the derivative. And I'm going to input my x value, which is 0. And I get here that dy dx is -0.499999, etc., which you can also say is -0.5 or -1/2, or you can just use this point altogether. So this would be -0.4999. So now when I write the equation to find the equation of the line, it would be y minus 3, because of my point of tangency, is equal to -0.4999 times x minus 0. And this would be the equation of that line. Now it says here, at what ordered pair other than 0, 3 does the graph of line L intersect f of x? And you can see here that this line intersects the graph right here. So we need to figure out what this point is. That's the ordered pair it's asking for. So I'm going to go to my calculator once more. Now that I know the equation of the line, I can graph the line. So that way, when I graph it, I will have it here and I can find that point of intersection. So I'm going to go down here. Now, when you're writing the equation of a line into the calculator, you can't put y minus 3 because as you can see here, it's just y. So what we would have to do to to plug in the equation of the line into the calculator is you would have to isolate the y, meaning just add the 3 over. So I can take this and I have y minus 3 is equal to negative 0.4999, and then x minus 0 is just x. So I add the 3, and the equation is y equals negative 0.4999 x plus 3. So this is what I'm going to input into my calculator. X plus 3. All right, and we want to graph them both because the calculator can find those points of intersection if you have them both graphed. So there is that point of intersection. So I'm going to go to second calc and I'm going to select option 5. It's going to ask you for the first curve, which you'll see that the X is already blinking on one curve and you press yes. And then it's asking for the second curve, so we'll press enter. And then it's asking to guess. And now the reason for that is because the calculator recognizes that there could be multiple points of intersection. So if I put this blinking X on top of this point of intersection, it's going to give me what this coordinate is. So instead, I'm going to drag my X over to the point of intersection that I want, which is this one here. So I press enter, and it's giving me exactly that point of intersection. So that ordered pair is 3.3899 and 1.3053. So 3.3899 and 1.3053. Let me just verify that, make sure I wrote it right. Yes, okay. Now the reason part C is asking for this question is because we need that point of intersection to find the area of region S. Region S is the area between the line and the curve. So the line is my higher function and the curve is my lower function. And their points of intersection are this one here, which is 0, 3, and this one here, which is this coordinate that we found. So when I write out my integral, the region S is going to be from x is equal to 0 to x is equal to 3.3899. Remember that these limits of integration are x's, so make sure that you use the x values. And then we're going to do the line, so that is the negative 0.4999x plus 3 minus f of x. So x to the third over 4 minus x squared over 3 minus x over 2 plus 3 cosine x. Now we don't have to actually integrate all of this or even combine like terms if we don't want to. We just have to be able to put this into the calculator. So I'm just going to at least distribute the negative. So this is going to be the integral of 0 to 3.3899 of negative 0.4999x plus 3 minus x to the third over 4 plus x squared over 3 plus x over 2 minus 3 cosine x dx. So I'm going to put this into the calculator now. Now this is part D, so I'm pretty much done with everything that was here. So what I'm going to do is I'm going to deselect this one, and I'm going to use this since that is the beginning of my integral here, and I'll just put the rest of the function next to it. So minus x to the third over 4 plus x squared over 3 plus x over 2 minus 3 cosine x. And now I'm going to go ahead and graph that. Your graph is obviously going to look different than what we have pictured behind us because this is an entirely different function. So now I'm going to integrate based on these points of integration here. So I go to second calc and we're integrating, so option 7, my lower limit is 0 and my upper limit is 3.3899. And you'll notice that when it shades it in, those points of intersection are now your zeros. So when you graph your new function, you'll see that it should stop at the x-axis. And so my area here is 6.9825. And this would be my answer. Let's look at one more. This is another calculator question. So what I'm going to do is I'm going to go to my calculator and I'm going to just erase everything, just so that I'm ready to go. Okay. Picture below are regions R and S, which are formed by the graphs of f of x is equal to 1 over 4 plus sine of pi x, and g of x, which is equal to 4 raised to the negative x. Identify the points of intersection of f of x and g of x. Okay, so first of all, how do I know which one is which? And the good thing is that here the calculator is going to do it for us anyway, so it's not a big deal. But just so that you know, this is primarily a sine function, so it's got to be a wave. Now, even though we don't see the entire wave, this is a part of a wave here. So that means that this, what looks like a parabola, this is f of x. And then g of x, it is an exponential function because we see that we have the variable in the exponent. And because the exponent is negative, that means that it is it's a decaying function. So it would go down. So this one here, this is g of x. So let's go ahead and graph both of these functions. We have the 1 over 4, plus sine of pi x. So that's 1. And then the other function is 4 raised to the negative x. And now let's graph and see what it looks like, and if I need to adjust my window, I'll adjust my window. Okay, so we see that the part here of the graph that they're focusing on is this little piece right here. So I'm going to adjust my window accordingly. So I'm going to start at x is equal to -1, just so I can have a little bit of space here. And then I'll stop at like x is equal to 2. So let's go to here. I'm going to go from -1 to 2. And then I'm going to also reduce my y values. So this is also, it's all above the x-axis, so I'll start at 0 and go to 2. Let's see if that works. Okay, this is good enough because it's this section right here. So let's identify those points of intersection. That is this point here and this point here. So we're going to go to the second calc menu and we go to option 5. It's going to ask you to select the first curve, the second curve. I want this point. And I get this point of intersection, 0.1782 and 0.7810. So I'm going to call this point here point A. So A is 0.1782 and 0.7810. 0.7810. Now I'm going to call this point here point B. So now let's find that point of intersection. So I go again to my calc menu, option 5, first curve, second curve. It automatically does that for you. The only time that you really need to move your X is when it asks you to guess for the point of intersection, which would be this one here. And we get 1 and 0.25. Okay, so now that we have both points of intersection, we can answer the rest of these questions. The first one here says to find the area of region R. Now region R, we see here that we have g of x, and then this here, this is f of x. So when I set up my integral, I see that the area starts at x is equal to 0. So I'm going to set up my integral here from 0 to the x value of point A, which is 0.1782. And this would be g of x minus f of x dx. Now I'm going to plug in what g of x and f of x is equal to, so I can make sure to input this into the calculator correctly. So this is from 0 to 0.1782 of g of x, which is 4 raised to the negative x, minus f of x, which is 1/4, plus sine of pi x. I'm going to distribute the negative so I can input it, like I said, into the calculator the right way. So 0.01782 of 4 to the negative x minus 1/4 minus sine of pi x dx. So I'm going to go to my calculator. Now I'm going to keep these graphs here just in case. So I'm just going to deselect them, and I'm going to come down here, and I'm going to input all of this. So 4 raised to the negative x minus 1/4 minus sine of pi x. And now we'll graph that. So now we're going to integrate second calc, option 7. My lower limit is 0. My upper limit is 0.1782. And it's going to shade that little area, and we end up with an answer of 0.0647. And this would be the area of region R. Now we're going to find the area of region S. Now S is the other way around. We have f of x on top and g of x on the bottom. And then we have 2 points of intersection. We have A and B. So when we set up this integral, it would be from the x value of A, so 0.1782, to the x value of B, which is 1. And then we have to do f of x now minus g of x. So that would be f of x here, so 1/4 plus sine of pi x minus g of x, so 4 raised to the negative x dx. And this is already pretty much simplified out for us, so I'm going to come here to my calculator. And again, I am going to deselect this one and start a new one here. Notice that I don't erase any of my functions just in case I ever need to go back. If I feel like I need to check my work, or if I feel like I made a mistake, I don't have to retype these functions. So 1/4 plus sine of pi x minus 4 raised to the negative x. And now I'm going to graph. Okay, So now we're going to integrate. We go to second calc, option 7, and my lower limit is now 0.1782, and my upper limit is 1. And I get 0.4103. And that would be the area for region S. Now it says to find the area of the unshaded region bounded by F, G, and the x-axis. So what they're referring to is this section here. Because this is F, this is F, this is G, and then this is the x-axis. So in order to find that area, we need to know all of those different areas beneath the curve. So we see here that we have, this is here, this is f of x. Then this here, this is g of x. And then in this little part here, don't let it trick you, this is f of x. So we have 3 different integrals that we would need to set up. So we would go the integral from, we start at 0 to the point of intersection of A, so 0.1782 of f of x, plus the integral from the x value of A, so 0.1782 to the x value of B, which is 1, but now of g of x, plus, now here I need, I know that this x value is 1, because that's that point of intersection for B, but I need this x-intercept. So actually, before I can even finish writing this, I would need to know what that x-intercept is. So I'm going to put here f of x is equal to 0, and I need to find that point of intersection. So f of x is this function here, so I'm going to go to my calculator and see how now I can deselect this one because I don't need it anymore. And I'm going to select only f of x. Now let's graph it. So this is the point of intersection that I'm looking for, this x value. Now, in order for me to find this x-intercept, you know how you have to go below the x-axis and then above the x-axis. So I'm going to adjust my window a little bit for my y's. I'm going to put -1 so I can go below. So again, I need this x value here. So I'm going to go to second calc, option 2 for 0. I'm going to go to the left and then to the right. And I get at 1.080. 0, and I think I saw a 4. Yeah. So this is going to be 1.0804, and then our function here, which is f of x dx. So now let's find these values. I already have f of x graphed, so I can actually already integrate this one here and this one here. So let's go do that. So I'm going to go to second calc, option 7. Let's do that first integral, so from 0 to 0.1782. And I get there that we get 0.0931. Now we're going to also get this integral here since f of x is already graphed. So we go to second calc again, option 7, from 1 to 1.0804, and that's going to give me 0.0099. And I'm doing these two so I don't have to go back and forth with our graph. So now let's get that integral in the middle. So I'm going to go back to my y equals menu, I'm going to deselect f of x, and I'm going to select g of x. So now let's go to the calc menu, option 7, integrating 0.1782 to 1, and we get 0.3831. So now to get our final answer, we just have to add all of these together. So I'm going to go back to my calculator here, and I'm going to quit, and I'm going to come here to my main screen and just add all of these numbers. So 0.0931 plus 0.3831 plus 0.0099. And I get my final answer of 0.48861. And that's it. That's the area between two curves.